we're going to go back to the example of last video. So y is 10 numbers, x is also 10 numbers taken from a random distribution, and z is actually 5 levels where D is the reference category. So let's say I would like to perform standardization. And standardization makes sense if you have like multiple numeric variables. So let's just add another x2 and maybe make it 1, 2, 5, and then repeat it twice. Yeah. So now we can also add this variable next to the equation. Okay, so let's first run the regression without this scaling commands. And let me just remove this last because that one is not so useful for this assignment. Okay, so x relates to y by minus 0.26 and x2 by 0.14 or 0.15. So if we would scale it, then this means that here it is a 1 point increase in x leads to a minus 0.26 decrease in y. Same for x2, a 1 point increase in x2 leads to a 0.15 decrease in y. Now, if we would have scaled these variables, the interpretation differs. So you also see that these coefficients now are different. So what does it mean? It means that a 1 point increase in x is still a 1 point, but this 1 point, it now means standard deviation. So it's no longer a point on the original scale like we had here, but it's a point on this in terms of standard deviation. Yeah. Now, how can you maybe understand this a little bit better? So if we would say look at the standard deviation of x. Let me just put it here. And the standard deviation of scale of x. Now, the normal standard deviation would be 0.77, but if I standardize it, it now becomes 1. And this is exactly the 1 point increase that we interpret here. So a 1 standard deviation increase on x leads to a minus 0.18 decrease in y. And this is also in terms of standard deviations of y. So a 1 standard deviation increase in x leads to a 0.18 decrease in standard deviations in y. Yeah, and the same holds also for x2. Now, I think so far it's okay, but now let's treat this more complex situation where you have NAs. So let's say, I have like this, I create this data frame again. So let me take the code that I used. Yep. So I'm going to create this data frame with now x2, and I'm going to make some DAs, NAs. So let me make an NA on x2. And yeah, so now, okay, we're going to do this lm function again. You're going to see that they are somewhat different, or actually they're not, because I don't say that they are from D. So let me just say that they are from D, because now it took like the reserved objects. Yeah, so as you can see now I have like different coefficients. So how come? Because one case is deleted, the one with the NA. Yeah, so as you can see here now, the third case of x is actually a missing variable. Now this line of code is now completely deleted from my my data frame. Now the only problem is that this scaling command is still done on the whole, on the 10 observations of y, while the lm command is done on only actually on this part, right? It's only on these 9 lines without the NA. So this creates some confusion, because here the scaling command, it actually uses the mean over all of y, while the LM, you know, should actually take the mean of only those 9 cases. So how do we solve this? Is by first, you know, make sure that we perform listwise deletion, and then perform the LM again, but now on the listwise deleted variables. So now we scale only on those. Well, actually, we can delete this. So as you can see, indeed, they are different from what we have seen before. Yeah. So it's not a big difference because it's only one missing value, but still you see some difference. Yeah, so please be aware that the NAs, that if you have NAs in your data and you perform standardization, you first have to perform listwise deletion on all the variables that are included in the regression.